Hello, welcome to this lesson in circuit analysis. We're going to finally use these equations that we've been developing to convert between line to line and line to neutral voltages. We have a couple of simple problems. These aren't really full-blown circuit problems. They're really just learning how to use the equations that we've developed to convert between line to neutral. And then in the next couple of lessons, we'll actually dive into some real problems where we do the entire end-to-end thing. But for right now, I just want to show you how to use those equations so that that part of it is at least solidified. So I have two problems. Let's take the easier one first. The B to N voltage in a positive phase sequence circuit is 120 at an angle of 60 degrees. Find VBC. So this is a typical problem that you would have to do, or this would be just a fragment of a larger problem that you have to do before you can actually solve the circuit. It's a very simple plug and chug type of thing, but if you don't have the tools that we've learned about so far, it seems very complicated. So first of all, you have to translate a few things. The B to N voltage, that means VBN. That's the voltage from terminal B to the neutral terminal. In other words, that's a line to neutral voltage. This is how you translate this. The line to neutral voltage for the B phase is, notice the phase sequence is positive, that's important too, and they give you the value. And then they're asking you to find VBC. So you should by now know that when you have voltages like AN, BN, CN, those are line to neutral voltages. And when you have AB, BC, CA, those are line to line voltages. If they're not clear to you now, it'll become second nature as we solve more and more of these problems. So to translate this guy, basically they've given you the line to neutral voltage. For the B phase, they want you to find the line to line voltage for the B phase, essentially, is what they're asking you to do. So you always start in exactly the same place. You write down your master equation. So the master equation, the one that I told you, this is the one that you're going to have to remember. I'm going to write it down exactly as we did before for the A phase, right? So VAB, if this were an A phase problem, it would be the root of 3. Then VAN, the line to neutral voltage for the A phase, at an angle of plus or minus 30 degrees. Now this problem doesn't deal with the A phase, and also now we know that the phase sequence is positive. We know that we choose the top sign if the phase is positive, ABC sequence is positive, and the bottom sign if the phase sequence is negative. So I want you to always start by writing this down, because if you start translating in your head to a different phase with a different phase sequence, you're going to eventually make a mistake. So always start your problem by writing down what you know. This is true for the A phase, always. So then we go and write down what is it for this problem. Now we're not dealing with the A phase, so what this is really telling you is the line to line voltage, VBC, is equal to the square root of 3 times the line to neutral voltage, VBN, that's B to the neutral terminal. And the phase or angle here, since it's a positive phase sequence, we discard the bottom sign, we call it plus 30 degrees. This is the equation you're actually going to use. You always start by writing down what I've taught you, choose the correct sign, substitute in for the correct phase or whatever you're dealing with. This is what we're going to actually use. Now your problem should be a lot clearer. The B to N voltage is this guy, it's given to us. So we're going to stick this in here, and then we're going to calculate what comes out the other side. And that's very simple. So what we have is VBC is equal to the square root of 3 times VBN, which is 120 at an angle of 60 degrees. That's the phasor of the B to neutral voltage, right? And then over here, we just kind of stick a plus 30 degrees as a lone phasor over here. And you can, in your head, you can put parentheses around it if you want, you don't have to. But there's an implied 1 out here. So what's happening is you're taking that 1 times the 120 times this. That's going to give you the new magnitude. VBC is going to be 207.85. And now you have a phase angle times a phase angle. And we already talked about, since this is complex exponentials, you add the angles. 60 plus 30 is 90. So you write it as plus 90 degrees. Very simple. That's it. All right. Now, if I would have not done any derivations of anything, then you could probably do the math, but you wouldn't really know what you were doing, and you wouldn't know where any of it came from. You wouldn't know really why there was a plus or minus here, or why you choose the top sign for a positive phase sequence, and why you choose the bottom sign for a negative phase sequence. You wouldn't really know unless I went through it why you're multiplying these magnitudes and why you can just add these phase angles together. I showed you why, because of complex exponentials, we're doing that stuff. Now that you understand all of that, the math itself is exceptionally easy. I mean, there's no calculus here. You're just multiplying numbers and adding numbers. That's it.